So welcome, we're back in chapter 6. We're going to keep going. We're in the last section, 6.6, which is about something called phase shifting. So we've been graphing things like this, a sine or cosine of omega x, and then possibly plus something. So this A is a vertical stretching or compressing. This omega changes the period. It's a horizontal stretching or compressing. This here is just a vertical shift. And the one thing we haven't accounted for is a horizontal shift, which in trigonometric language is called a phase shift. So there it is, okay? If we add or subtract something inside that parenthesis, it's called a phase shift, and it will be expressed as a horizontal movement. Okay, and we're going to focus really on that first objective in this first video. There's going to be a second video that accomplishes the second. Given a chart of data representing some sort of real-world phenomenon, can you build a sinusoidal function that models it? So let's just refresh some stuff. So we already know this number out in front, the amplitude is the absolute value of that number. We also know the period is 2 pi over omega, where omega is the number multiplying the variable x. We also know the vertical shift is given by this number b. Now the phase shift, aka how much right or left do I move, is given by the ratio phi over omega. And that can either be a leftward movement or a rightward movement. Now up here at the top, since this formula already has a minus sign baked into it, if phi is negative, then you actually have a plus there, and that's a left shift. If phi is positive, then you have a minus sign, and that means it's a right shift. So because the formula already has a minus in it, this looks a little backwards to what you're used to, but it's actually the same just because we already have a minus sign in there. Okay. Why is the phase shift, the right or left movement, phi over omega and not just omega? It's because what you would do to determine the phase shift is factor this omega out. Okay, and a note on notation. This is the Greek letter phi. It's a sort of tall, skinny thing with an almost vertical line through it. It's not this, that's a different symbol, but because they're so similar, when we write by hand, we tend to use something different, and it's just like a swoop with a downward thing through it. This is a handwritten phi. So when you see me write it, I'm going to use that symbol rather than this one, but when they're typeset, for example, in a book, they'll tend to use that symbol there. Okay. So let's do an example. Find the amplitude period phase of this trigonometric function and then try to graph it. Okay, so we're going to do the same 4 steps as before. We notice we have a sine curve, and we compare it to the desired form. Notice we do want to factor this 2 out. So we started, oh, here it is. We started with 3 times the sine of 2x minus pi. If you factor that out, okay, it'll look like that. You kind of quickly identify, yes, A is 3, omega is 2, phi is pi. Great. So the amplitude is 3, the period is 2 pi over omega, which simplifies to pi, and the phase shift is phi over omega, which is just pi over 2. And since phi is positive, that is indeed to the right. Okay. So we have an amplitude of 3, which means we are trapped between a height of 3 and negative 3. Normally, the picture would start at x equals 0, but we have shifted right by pi over 2. So we start this at pi over 2. Where does it end? It ends at where you start plus 1 full period. So pi over 2 plus pi, aka 3 pi over 2. So when I draw this picture, it's going to start at pi over 2 and end at 3 pi over 2. It's also handy to do 1/4 period. Well, if the period was pi, then the quarter period is pi over 4. So from the beginning, I'm going to shift by quarter periods until I reach the end. So from pi over 2, which is where I begin, if I move forward by pi over 4, my next key point is 3 pi over 4. If I move forward by pi over 4, my next key point is pi. If I move forward by pi over 4, my next key point is 5 pi over 4. If I move forward by pi over 4, my next key point is 3 pi over 2, which is where we ended. So what we need to do is figure the corresponding y values. Now, the way the book presents it, it just sort of seems like they're plugging it in. There's a way that you can do this that's, I think, a little more intuitive, which is to say, the function we were graphing was 3 times the sine of, what was it, 2x minus pi. Yeah. Okay, so this fundamentally is a sine curve with a positive coefficient. It's going to look like that. Sine curves begin at their median and go to their max. And we know the maximum here is 3 because the amplitude was 3. Then they go back to their median, which for a sine curve is 0, back to their minimum, and we know this has amplitude 3, so the minimum is -3. And then it's going to end back at its median. What x values? We had a right shift of pi over 2. Then I shift by quarter periods, so I go forward a quarter period and I end up here. Then I go forward a quarter period and I'm at pi. Forward by a quarter period is 5 pi over 4. Forward by a quarter period is 3 pi over 2. So there's the graph we're going to draw. The book is just going to draw a nice computer-generated one. Okay, so there it is. It's all the same points as before. And if you need to or are instructed to, you can extend this to have multiple periods in it. Okay, just keep doing the same pattern over and over again. Okay, you could also do it using our standard transformations. So first, if we multiply by 3, so we start with our normal sine curve, okay? It goes from 0 up to 1, down to -1, and it has a period of 2 pi. First, we accomplish this 3 by stretching the heights to go to between plus or minus 3. Now we accomplish this horizontal compression. So all of my x coordinates get multiplied by 1/2. So now it ends at pi instead of 2 pi. And now I accomplished my shift right by pi over 2 units. So the same picture that started at 0 now starts at pi over 2. So you can do it that way as well. Okay. So another example. Find the amplitude, period, phase shift, and graph. So I'm going to show you a way to do this that I think is more intuitive than the book. It's fundamentally the same work. But what we want to do is identify first, what shape is this? Is it positive sine, negative sine, positive cosine, or negative cosine? So before we can do that, check if you need to factor anything out from the inside. So we don't want a negative omega. Okay, here it's not, so there's nothing to do. So we have a positive cosine shape. So my shape for positive cosine starts at its maximum and then does one of these. So I draw the correct shape. Next, I want to identify what are the x and y coordinates of all of the key points. Okay, once I label all of these, we're done. So what I need is y coordinates and x coordinates. I happen to think the y coordinates are easier to get. Okay, so I'm going to erase our shape information so we can start working through our heights. The vertical shift is always your median value. So this vertical shift is our median. So at our median points in the middle, I put a height of -1. Your max is going to be median plus amplitude, and your min is going to be median minus amplitude. Okay, what's our amplitude? It's 4. So from my median of -1, if I add 4, I have a maximum height of 3. If I subtract 4, I have a minimum height of -5. Great, all of the y coordinates are now labeled. Now let's figure out some x coordinates. So normally this curve would start at x equals 0. So I need to determine if I've shifted left or right, and then I need to determine my period. So what we want to do is factor this 2 out. Alternately, I guess to match the way it was done before, we have omega equals 2, and phi is equal to -3 pi, because remember the formula normally has a minus there. So since it's a plus, I need to express this as -3 pi. And my shift is just going to be by phi over omega, which is -3 pi over 2. So instead of starting at 0, I start the curve at -3 pi over 2. Okay, now I've determined where the curve starts. Next we ask what's the period, and therefore what's the quarter period, because if I can just add a quarter period from where I start, I know I'm going to fill in all of my missing x coordinates. So my period is 2 pi over omega. That's 2 pi over 2, which is pi. So a quarter period is pi over 4. So then I started at -3 pi over 2. So my next point is at minus 3 pi over 2 plus a quarter period, which is pi over 4. Give these a common denominator and simplify, and you'll end up at negative 5 pi over 4. So that's the x-coordinate of the second point, negative 5 pi over 4. My next point will be at where I was, negative 5 pi over 4. Add a quarter period, pi over 4. This simplifies down to minus pi. So that's my next x-coordinate, minus pi. Add pi over 4, get to minus 3 pi over 4. Add pi over 4, get to minus pi over 2. Now I've labeled the x and y coordinates of all of our key points, and we're done. Okay, so that's how I tend to do these problems. First, identify a median value through your vertical shift. Identify your shape, positive or negative sign or cosine. Identify your amplitude and your vertical shift. Then you get all your y coordinates. Then identify your horizontal shift and a period, and then you can fill in all your x coordinates. So the book does it using basically the same steps, but with a nicer picture, so we'll go through it. So the first is to identify what we have here. We have a cosine curve, great. We identify that a is 4, omega is 2, and phi is negative 3 pi, because remember this formula is supposed to have a minus there. So the amplitude is 4, the period is pi, and the phase shift is minus 3 pi over 2. This is all work that we did in the other method as well. So there's a bit of a typo in the book. They're going to ignore the vertical shift for a bit. So ignoring the vertical shift, the graph will be between negative 4 and 4. It will start not at 0, but at the phase shift of minus 3 pi over 2, and it will end at phase shift plus period, which works out to be minus pi over 2. The intermediate points, they just add a quarter period, just as we did, and here's all that computation, same as we did before. From the starting point of minus 3 pi over 2, consecutively add pi over 4 until you've done it 4 times, until you've done 4 quarter periods. That'll give you 1 full period. Okay, and these are the values. They're the same ones we got. A lot of this work is exactly the same. So here are the 5 key points. And again, they haven't accomplished this vertical shift yet. So a cosine curve goes from its maximum to its median to its minimum, then to its median and maximum. And we haven't accomplished the vertical shift yet. So plot these points, and then you'll have a graph of this thing without the vertical shift, and here it is. But then you can extend the period, extend the graph to cover multiple periods, and then accomplish the vertical shift. So everything that was at height 4 is now at height 3, here at the top. Everything that was at height 0 is now at height minus 1, there in the middle. Everything that was at height minus 4 is now at height minus 5. And the graph that we constructed was this one right here, from negative 3 pi over 2 to negative pi over 2. We just gave 1 complete period. Okay. So I want to do a couple more examples like this. This is the only example like that that the book does. But let's do a nice complicated one. Graph 1 period and label key points for y is equal to, how about 6 times negative 3x plus 1 plus 8. Great. First things first, I don't want a negative number multiplying my x. I don't want omega to be negative. Oh, I didn't put a sine or a cosine function in there, sorry. 6, and let's do a sine. Okay. So the first thing I want to do is factor out that minus sign. But I have to be kind of careful because I have to factor it out from the whole thing here. So if I factor that minus sign out, what's left behind is 3x minus 1. Now I can identify my shape, a negative sine curve. Okay. Next, I want to identify my amplitude. It's the absolute value of negative 6, aka 6. Next, I want to identify my max and my min and my median values. So the median value is just the vertical shift. That's 8. Okay. My maximum is, let me write this out in a little more space. So the maximum is median plus amplitude. I know my median is 8 and my amplitude is 6, so this is 14. The minimum is median minus amplitude. That's going to be 8 minus 6, aka 2. Okay, and the median is just that vertical shift of 8. So I know my max, my min, my median are respectively 14, 2, and 8. Okay. Next, we want to accomplish period, quarter period, and phase shift. And once we have all of that, we're going to be able to draw a graph and label points nicely. There's my neighbor's dog barking, as always. Okay, so my period is going to be 2 pi over omega, which is 3, which means a quarter period is 1/4 times that, which works out to be pi over 6. Okay, my phase shift is 1 over 3. Okay, notice this already has a minus sign now because when I did the factoring, that introduced a minus sign. So I don't have a negative phase shift, I do have a positive phase shift. So this is phi 1 over omega 3. And since this is now a positive quantity, this is to the right. Okay, and now we're good. Now we can start drawing. So first things first, what was the shape? Negative sine curve. There is a sine curve, but reflected, a negative sine curve. Now I know I need to label these 5 points. Okay. My max, so I need x and y coordinates for everything. My maximum height is 14, my minimum height is 2, and my middle heights are all 8. So now those y coordinates are all labeled. Where do I start? Well, I shifted 1/3 to the right, so started at 1/3. Then what do? I do 1/3 plus a quarter period of pi over 6. Then I do 1/3 plus 2 quarter periods, 2 pi over 6. Then I do 1/3 plus 3 quarter periods, or 3 pi over 6. And finally, I have 1/3 plus 4 quarter periods, 4 pi over 6. You can simplify these fractions down. 2 pi over 6, for example, is pi over 3. 3 pi over 6 is pi over 2. And 4 pi over 6 is 2 pi over 3. Honestly, I consider it optional, because right here you can get this pretty easily. And if you write this down on an exam, especially with the supporting work off to the side, I can very quickly see you did it exactly the standard way and your computations are all there. Also, if you start making mistakes, if you do things like decimal approximations, it's much harder for me to figure out where you went wrong. Okay, and I don't give you the benefit of the doubt. If something is wrong and I can't figure out what happened, you're going to lose points. If something is wrong and I can tell based on your work, which is presented in detail, that you accidentally said 8 minus 7 is 9 because you had a weird brain fart moment, I'll shrug and I'll say, well, we all do that. If it's the only time I see it, I might not take any points at all. If I see it a couple of times, I'll start to take off points, but not as many. Basically, if I can figure out what went wrong, it's possible that it's a forgivable mistake. If I can't figure out what went wrong, I have to assume that you just didn't know what you were doing. So let's do another example, but a little bit backwards. Okay, rather than here's a function, draw the graph, here's a graph, draw the function. So let's do, here's the graph of one period, and I'm only going to label a couple of points. I'm going to say this point here is at coordinates 6, 9, and this point here is at coordinates, let's say, 11, 8. Okay. What's a function that produces this graph? Now, there's no unique answer, but there is a standard process that'll get us to one. So we need to determine first, what shape is it? Is this positive sine, negative cosine, or negative sine? This is a negative cosine shape. So fundamentally, I want something that looks like this. Negative something cosine, omega x minus phi, and then there's a vertical shift. Now all we have to do, now that we know the general form, is figure out what all of these things are. Okay. So let's work with y coordinates first. I recognize now that my maximum is given as 9 and my minimum is given as 8. So from this, we want to be able to figure out our amplitude and our vertical shift. Now, the amplitude is the distance between the maximum and the median. Alternately, it's the distance between the median and the minimum. Okay. What this means, if I add this to this, on the one hand, I'll have a plus a, so twice the amplitude. But if you add max minus median to median minus minimum, what you get is max minus min. The difference between the maximum and the minimum is twice the amplitude. If you had been given a point at median height, you could just read off that the distance from median to minimum is exactly the amplitude. But in this example that I put up, you don't have a median height. You could find it, okay? But twice the amplitude is the max minus the min. Okay, so we're going to use that information and say, so twice the amplitude is max minus min, which is 1. Therefore, the amplitude is 1/2. Okay, so now I can come down to my function, and instead of an unknown a, I can call this 1/2. Great. We can also find our vertical shift. Okay, our vertical shift is going to be the median, and the median is the average of the max and the min. Okay, so the median, the vertical shift, is the average between the max and the min. And this doesn't really simplify, it's just 17/2. You could call it 8.5 if you want, but I prefer to work with fractions. But now we take our unknown b and we say it's no longer unknown. It's exactly 17/2. Okay, so we're making progress. Next, let's address the x-coordinates, aka the period and the horizontal shift. So in order to determine the period and the horizontal shift, we need to use the information we're given, which looks kind of incomplete. So let's be a little clever about it. Okay. This distance is not one full period, but it is 1/2 of a period. What's the change in the x-coordinates? Well, I went from x equals 6 to x equals 11, so a half period is 5, therefore the period is 10. Okay, if we wanted to label more points on the graph, I now know that this x-coordinate is 10 back from this one. In other words, this x-coordinate is 1. And it's down at the minimum, which I already know is 8. So if the period is 10, that means that 2 pi over omega is 10, multiplied by omega, 2 pi equals 10 omega, divide by 10, and get omega is equal to pi over 5. So now omega is no longer unknown. So I come down, not highlighter, I come down here and I say, great, omega I can replace with pi over 5. Now the only thing that's left unknown is the phase shift phi. Okay, eraser. So here's what I know. I know that the horizontal shift at the end of the day is given by phi over omega. Okay, so the horizontal shift is phi over omega. We've already determined that since the period is 10 and we ended at x equals 11, we began this curve. Oh, no, go back. Since this curve ended at 11 and its period was 10, that this curve begins at x equals 1. So my horizontal shift was 1 unit right. In other words, phi over omega equals 1, so phi equals omega, which is pi over 5. We already found it. So I come down here, not highlighter. So I come down here and I say, all right, instead of an unknown phi, let's just call it pi over 5. And now we have constructed a sinusoidal function that exactly matches the graph that was given. So this is something else you should get comfortable doing. The problem that says, here's a function, can you draw the graph, is not something we generally ask on exams or quizzes, because a lot of students will just punch it into their calculator, copy a picture, give no supporting work, get 0 credit, and then they get very upset. However, here's a picture, figure out the function is not something that you can just copy and paste into a graphing calculator or into Google and then just blindly copy the result down. You have to understand how the amplitude, the vertical shift, the period, and the phase shift all interact with one another to produce a given graph. So going from the graph to the function is much more likely to show up on an exam or quiz because it's not something you can fake your way through just by punching it into a calculator. Okay. And you can practice it on your own quite easily. All you need to do is to just practice this on your own, draw a shape. Let's do a sine curve. Label a couple of points. make sure to give yourself at least 2 different heights. If I give 2 different points and they're at the same height, you're not going to be able to determine the amplitude. So label 2 of the key points at different heights, maybe this one and this one. Label coordinates in a way that makes sense. So from the left to the right, the x coordinates have to go up and the y coordinates have to go, up or down depending on what's bigger. So maybe I label this as 9 at a height of 12. The x coordinate has to be bigger, like 68, and the y coordinate has to be smaller, like -100. Great. Now I have a shape and I have 2 points at different heights labeled. So I quickly compute. The amplitude is the distance between these. That's 112. Okay, from 12 to -100, the distance is 112. This right here is only going to be 1/4 of a period, but the change in x coordinates was 59. Therefore, the period is 4 times that, which is 236. Okay, what's my shape? It's a positive sign. Okay. My vertical shift is my mean height, which was already given at -100. So I replaced the vertical shift with -100. Okay, my amplitude we already figured out was 112. My period is 236, so 2 pi over omega is equal to 236, from which I deduce that omega is 118 over pi. 118 pi over 118. I just had it reciprocated. So I can come down here and say, no. Instead of omega, I want this to be pi over 118. Where did this graph start? Well, from 68 to 9, I had to move left by 59 units. So if I move left another 59 units, this is going to be at an x-coordinate of -50. So my horizontal shift was -50, which is going to be phi over omega. We already determined that omega is pi over 118. Okay, and if I just determine phi from that, we get phi is, gosh, what's 50 times 118? 5,900. Is that right? Yeah, I guess so. Okay, and it's negative, so phi is negative, so this becomes a plus. 5,900 over, pi over 5,900. Yeah, and there we have it. It's pretty quick, okay? And the way you can test this is, if you have a graphing calculator, I know I want this to start at x equals -50. 1 full period later will be at 186. I know the maximum value is 12. Okay. The amplitude is 112, so I go from my median is now at -100. So the minimum should be at -212. So just set your graphing window. X goes from -50 to 186. Y goes from -212 to 12. And it should perfectly fit this shape of the function, as long as you enter this in and you are in radians mode. So that's how you can just draw a shape, label 2 points at different heights, figure out the function, and then check it by comparing it to a graphing window using your x values and y values for your start end and your min max to tell the window to be exactly fitting what you're hoping to show. Okay, so practice that. Be sure, feel free, to ask questions during office hours or email me if you have more. Otherwise, we're going to come back in the next video and start matching data to curves to try to predict phenomena.